So I want to talk about a few examples of integration with area versus total area. So, all right, let's say that I just have some theoretical graph here, so this f of x. And so every time the graph crosses, it's going to start at 0, and then it crosses at a, b, and c, okay? So first of all, if I just wanted to calculate like the area kind of contained by this graph, so I could set up this integral, and let's say I set up this integral, so I want you just to notice that I'm going from 0 to c. So this is going to calculate then the area of this spot, and this spot, and that's what this 8 is going to come out to. But what does that 8 actually mean? Where does that come from? Okay, so if I were to break this up between kind of where each part of this graph crosses, each graph is going to contribute its own amount of area to this 8. And so the thing is, when you fall below the x-axis, so we talk a lot about area, but what we mean in this case is like the area can go actually negative with integration, right? Because just because of like how the bounds are going to fall. So when I calculate all of this up, so really what's happening here is I'm taking this 6, this -5, and this 7, and all of those will contribute to making this area of 8. But what is total area? So total area is going to then be just taking the absolute value of all of these things. So I could just add each one of these, and so the total area in this case would be 18. So the word total area is kind of telling you that you need to like take the time for this. And so total area, as you can see, also can be a little tricky to calculate, because if you do have a graph that's going up and down and up, then what you're going to have to do, right, is you are going to have to calculate what's the area of this part, and this part, and then add them up like I just did here. So it can be a little bit tricky. Now, what if I just wanted to calculate the area of this part here? How would I set up that integral? Well, to set that up, okay, so this goes from this part A to this part B. So those are going to be my limits of integration, and then I would just go ahead and compute whatever this integral is. And so in this case, then, again, we would get that the area of this would be -5, but the total area would be just 5, right? Okay. So to throw this into an example then, so let's say that I want to find the total area of the shaded region of the curve. And I have a pretty simple curve here. I just have y equals sine of x. But okay, so this really has everything that I need to know. So really, area and integration, they go hand in hand. So a lot of times when you hear area, you are going to set up an integral. And so in this case, you're going to also use, so your limits of integration, this is where I start, this is where I stop. This is the lower limit, this is going to be the upper limit. And then as far as what am I integrating, it's just whatever that curve is. So here's what I'm going to integrate. Now, this one is a straightforward one to integrate. The only thing I'll say with this is just be careful with the signs. So I go ahead and I plug in my limits of integration. So this gets a little gnarly because you have minus, cosine of minus. So just be aware of that. But then, okay, so I go ahead and I work all of this out, and I've got all my work here so you can just follow along. But so this has an area of -2. But if I'm being asked to find the total area, that will just be 2. So you just want to keep that in mind. This works for all integrals. And so that's going to be it for this video. If you found this helpful, I would love it if you hit that like or subscribe button. And otherwise, I will talk to you guys in another video. Bye.